We know how React manages state, or at least we have an idea, but there's one thing which is important, which I mentioned before, but which I now want to emphasize again. And that is how React handles state updates. In your code, you might have a component, and in that component, you might manage some state with help of the useState hook. And therefore, React in the end manages that state for you. Let's say the initial state for this product component is DVD. So we have a DVD as a product here. Now, eventually, because a user clicked a button or whatever, in that component, we update that state. For example, with setNewProduct, that could be our state updating function returned by the useState hook. And we set the new product to book. So from DVD to book. Now, what happens with that is not that DVD is instantly, after setNewProduct finishes execution, is replaced. DVD is not instantly replaced just because setNewProduct is done running. Instead, calling setNewProduct and calling those state updating functions in general schedules a state update with the data book. But that's now a scheduled state change. React is aware of it. React plans on processing it. React doesn't process it immediately though. Now, in reality, most of the time, state changes, scheduled state changes, will be processed very fast, pretty much instantly. So in reality, it might feel instant. If we click a button and that removes a paragraph, to us as a human, that happens instantly. But React reserves the right of actually postponing that state change. For example, because a lot of other performance-intensive tasks are going on at the same moment, potentially tasks that React considers to have a higher priority. Let's say on your screen you have an input field where the user is able to type something. Reacting to that user input would have a higher priority than changing some text on the screen. And for reasons like that, React might postpone scheduled state changes. Now, what React does is it guarantees you that the order of state changes for one and the same type of state is guaranteed. So if we call setNewProduct again and we set this to, let's say, carpet or whatever, then this state change would not be performed before the previous state change. So the order is kept, but it's not necessarily executed immediately. Eventually, of course, it will be processed and your new state will be book. And once that new state is active, once that state change was processed, React will reevaluate the component, it will rerun the component function. Now, because of that scheduling, where of course you might have multiple outstanding scheduled state changes at the same time, because of that, because multiple updates can be scheduled at the same time, because of that, it is recommended that you use this function form for updating your state if you depend on the previous state snapshot. In a lot of cases, this will probably not matter because it's processed so quickly that you can't even click fast enough to see a delay. But because it theoretically could be postponed, this is the safe way of ensuring that state changes are processed in order. And for every state change where you depend on the previous state, you get the latest state. Otherwise, you might just get the latest state when the component function was executed last, which is not necessarily the same state as if the state changes are executed in order. Because if you have multiple outstanding state changes, they all come from the same last re-render cycle of that app component. They all come from that last component snapshot. But of course, if they were processed, the component would re-render in between. But since they're all already scheduled, all outstanding states changes don't take that new in-between component result into account. That's why this function form is helpful, because there, React will actually ensure that for every outstanding state change, it looks into the latest state and gives you that, and does not use the latest state from the last time the component was re-rendered. That's an important difference between when the component was re-rendered and when a state change was scheduled. You can have multiple outstanding state changes from one and the same component re-evaluation. That's the key takeaway here, and that's why this matters. That's also why in the last non-project module, where we initially learned about useEffect and so on, it was safe to actually update our form validity based on the email and password is valid states inside of useEffect. Because just like using the function form for updating a state based on a previous state snapshot, useEffect actually, because of its dependency mechanism, is ensured to rerun the effect here every time a state or a value, which is a dependency, changed. And therefore, you can't miss outstanding state changes, because here it will simply rerun this effect for every time the component was re-executed, the component function was re-executed. It will thereafter always rerun the effect, and therefore you are also guaranteed to get the latest state when doing it like this. So these are simply two different patterns for dealing with one and the same problem, you could say, depending on what you're trying to achieve. Here we want a state update that depends on some other states. In this case, on the other hand, we want a state update that depends on the same state, just a previous snapshot of that state. So that state update scheduling is a mechanism you have to keep in mind. Not because you actively need to do something about that. React manages those scheduled updates for you, but because you need to write your code accordingly to rule out any danger of potentially working with outdated data. You rule it out when using that. You rule it out when working with useEffect. Now, there is another important thing you need to know about state in React. There, we actually have this nav context, and in the navigate handler, I do something which you see a couple of times throughout this course. I call two state updating functions after each other. Now, we just learned that just because you call such a function does not mean that in the very next line the state was updated. State was not updated here. Instead, we just learned that the update will be scheduled and eventually the entire component will rerun, so this component in this case, and then once this component reran, then we have the latest state available, not earlier. Now that's what we learned. Now here, however, we have two state updating functions after each other. That clearly means that two state updates will be scheduled. Does this, however, also mean that the component will be re-executed, re-evaluated twice? You could imagine that this happens, but that's actually not what React does here. Instead, if you have two state updates in the same synchronous code snippet after each other, so not in a promise in different then blocks, but in the same function, for example, where nothing in between would cause a time delay or anything like that. So if you have two synchronous lines of code after each other, where you then call a state updating function, in such cases, React will batch those state updates together. In one long synchronous process, so for example in one function that executes start to end without any callbacks or promises in between, in such cases React will take all the state updates that are produced by that function and it will batch them together into one state update. So back in this picture, even if we would not just update the new product here, but if we would update something totally different in the same function, we would still just have one scheduled state change, which then, however, just changes two different states. But it's one process. It's not two scheduled changes with two upcoming component re-executions, re-evaluations, but instead it's one scheduled change where all the different states you might want to affect are simply batched together. So state batching is another important concept you have to be aware of when working with React. So we learned about use callback. Attached, you find a new mini example where I also want to dive into another hook that helps us with another optimization we could add. Here we have use callback to basically store a function to not recreate it. This is a function which I pass to the button through the onClick prop. The button internally uses React Memo, and because we store that function with use callback, the button will never re-render in this case, because its props never change, and React is aware of that. Now I'm also rendering a list here, and the interesting thing is that the list is sorted. It's sorted in an ascending way. Now, the data which I put into the list is not sorted. It's in random order, as you can tell here. So that means that, of course, obviously, in the list, we're doing some sorting. And indeed, here, I'm sorting my list with this simple built-in sort method, to which I just pass a function that defines how the sorting should happen. You can look up the sort method documentation if you want to learn more about that. And that gives me my sorted list, which I then output. Now, the thing is, sometimes in your code, sometimes in your components, you might have logic like this, which could be a bit more performance intensive. Obviously, that's a short list. Sorting will be quick, but for longer lists or simply for other tasks, you might have some code which takes quite some time. Eventually, this code of course needs to execute, but you certainly don't want to run this code every time the entire component is re-evaluated. Now, of course, we learned what we can do to avoid unnecessary re-evaluations. We can use React Memo here, right? With that, we can wrap the demo list. And with this shouldn't run unnecessarily. If I now console log demo list running here, we see that of course it runs initially. That means the list was sorted, but thereafter it shouldn't run again. Well, actually I have this button. When I click it, I change the title here. And the title is part of my list here. Therefore, when I click the button, demo list runs again, and it needs to run again because one of its props changed. The title changed. It has a real different value there. So React Memo is not failing. It needs to rerun in this case. Now, as a side note, of course, currently it would always rerun when the parent component re-renders though, because at least this array here is constantly recreated in the parent component whenever the parent component runs. So even if the title would not change, if the parent component would rerun for some other reason, the demo list component would be re-executed because we always generate a new array. Like functions, arrays are objects, objects are reference values, and therefore two arrays, even if they have the exact same elements in the same order, are never the same, because they occupy two different places in memory. But here we don't even have the problem, but instead, as I just explained, because the title changes, we have a valid reason to rebuild demo list. So sometimes the component reruns is re-evaluated, and still you might not want to repeat every bit of work you did there in the past, especially if the work you would have to redo is more performance intensive. And sorting is one of the more performance intensive tasks you can do in your components. So, is there a solution to that? Yes, there is. We have use callback to store function objects and only rebuild them when some input changed. We have something similar for all other kinds of data. And that is another hook which we can import, the use memo hook. Use memo basically allows you to memoize, so basically that means to store any kind of data which you want to store, just like use callback does it for functions. And here we could memoize, and yes, that's memoize, not memorize. These are two different terms, but it's pretty much the same here in this context. So you can memoize the result of this sorting here, simply by calling use memo here, and now use memo as a first argument wants a function. That is, however, not a function that will be memorized. Instead, that function should return what you want to store. So in this case, it should return that sorted array. Now, just like use callback, use memo wants a second argument, which is an array of dependencies. Basically, to ensure that this stored value is updated whenever one of the values you're using in there changes. And in this case, indeed, whenever items changes, whenever we get new items, we want to resort them. So items are a dependency here. We could add props here because items are pulled out of props. But that means that the entire props object is our dependency, and therefore this would essentially always recalculate. So a more elegant way is something we used on useEffect and its dependencies earlier in the course. We can use destructuring to pull something out of props, in this case, to pull the items out of props. And then we can just add the items here as a dependency and use just items here for sorting. And now this will only rebuild this if items changed. Now let's see when that happens. For that I can add a console log here, items sorted. Let's see how often this runs. If I reload, we see it runs initially, of course, but it still also runs when I change the title. Now the idea was that it shouldn't run there. Why is it running again then? Well, because items indeed changed. That's what I mentioned earlier, a few minutes ago. The items here actually are always recreated when app reruns because we always create a new array here. So even if it's technically a similar array with the same values in the same order, it's still technically a new array in memory, and that is treated as a brand new object which isn't the same as the old array, even if it contains the same values. That's this reference value thing I mentioned a couple of times throughout this module already. So to ensure that we don't unnecessarily pass a new array here, we can of course also use memo here. We simply import use memo, and then here we can wrap it, add this function which should return this array, and add our dependencies, which here is an empty array. We got an empty dependencies array here because here this of course never changes. It has no external dependencies. It's all hard-coded in here. So therefore now we also call use memo here, and of course we can also pull that out of there and say list items is the result of calling use memo, and then we pass list items here to items. And with that now we should not unnecessarily sort the list again. Now we see items sorted initially, but if I click change list title we don't see it again because of use memo. Now, I will say you will use memo far less often than you use callback, because memorizing functions is much more useful, and you need that more often than memorizing data. You essentially want to memorize data if it would be performance intensive to recalculate something based on it. Otherwise, it might not really be worth it, because you always have to keep in mind that if you store data with use memo, of course that occupies some memory, and of course this storing functionality also takes up some performance. So this is not something you want to use on every value you're using. If you got a scenario like this one here though, where you want to sort something, then it might be worth a look, because then using use memo and avoiding unnecessary sorting steps in future component updates, that might be very well worth it. Now, throughout this course, of course, we'll see more examples, and therefore throughout this course alone, you will get a better feeling for when you want to use what. In this module, I just want to put all those things out there and explain them so that you understand them and so that you are aware of them. When you use them, always comes with experience, depends on your preferences, your exact use case, and there also isn't a clear right or wrong. It's just something you should be aware of so that you can look into optimizations like this if you find out that your application is slow or that you want to improve some parts of your application.